All right, so in this particular application, we're going to take 2 weeks to go through it. So this is the part one, essentially the first week. And what we want to do is take a look at how we're going to digitize data that we might get from the literature. So why would you want to do this? Let's say you're working on your senior design projects and you collect some data. And the literature always is going to have similar experiments, and you like to compare yours directly with that in the literature. Or the analysis that's done in a paper that you've read just doesn't seem to fit the analysis that you're doing on your own data, and you think there might be something wrong. And so it's real helpful, especially in the older literature where you may not have access at all to the actual data in the paper, to be able to take the image of the plot in the paper you're interested in and grab the data points off of it, and now you've got their data and you can use it to plot with yours or to reanalyze. And so this is going to become very handy, and I think you all will use this with your senior design work. So let's go ahead, and what we're going to do is first we're going to just kind of review over some of the plotting in Matplotlib. And then at the end here, we'll look at how to interact with the plot to be able to just call points off of an image. And then next week, we'll look at refining this to actually do it on a set of data. All right, so let's go ahead and look at this, just review Matplotlib a little bit. We're going to look a little deeper. We've been using it to make plots. But if you've been looking at how we're doing it, there may be some pieces of it that are a little confusing. And one of the things you want to look at is the way that Matplotlib defines a plot or a figure, if you want. And so Matplotlib has something called a figure, and it has something called axes. And the figure is the overall box that contains the plot. The plot itself is referred to as axes, and so one figure could have multiple plots in it or multiple axes. Okay. And so that's how we're going to kind of define this. So if we do want to put multiple plots in one figure, then we would do that by defining separate axes that belong to the figure. Okay. So let's take a look at what this looks like in practice. So let me first go ahead and we'll import NumPy, and we'll import Matplotlib pyplot. This is the particular subpackage that we're using for Matplotlib. Okay, we're going to just generate some random data here. And so I'm just generating some random integers. You can see from 1 to 10 here. It uses 1 minus the high number. And then I'm going to take those and then just add on some other random numbers between 1 and 4 just to generate some data. And we're going to do 50 data points. Okay, so those are my separate XY axes. I could put that data together in the column stack command here. And so this would pair the XY so that I have pairs of data now as a NumPy array. All right, so that's what's going on there. So let me go ahead and run that. Okay, so here is just some blank plots. We're not using any data yet, but I just want to show you this command called Subplots, and this would allow us to create as many axes, right, or plots within our overall figure. So here I tell it how many rows and how many columns I would like in my overall figure, right? Each row and column position represents an axis or a potential area for a plot. So in this case, I've got 1 row of plots and I've got 2 columns. So I've got 2 total plots. And again, these are referred to as axes, so I could call them axis 1, axis 2. Okay, so this subplots routine kicks out as an output these 2 values. Okay, it kicks out an object for the figure, which is the overall, kicks out an object for the 2 axes that I can then add specific types of plots into. And then figure size gives me the overall size of the figure that contains these two, and that's how I can control overall how big this is. And so, for example, if I made this 18, okay, you can see that the size of the plot has expanded in the X direction, and the height is still listed as 4 here, so 9, right? We're getting nice big plots. Okay, I'm going to go ahead back and keep it a little smaller. There we go. So that's just showing you the overall layout. Okay, so we're going to go ahead and do that. So here's our first line. Okay, I'm going to go ahead and make those 2 subplots, just kind of filling out my form. And I've called the first box axis 1, this one axis 2. Okay, these names you can make whatever you like. You just have to then use these in the rest of your code. Okay. All right, so axis 1, right, which is the first plot, I'm going to do a scatter plot, and my data, so my X data is equal to X. That's this data up here, X and Y that I generated. My Y data is equal to that Y. I give it a marker. I can give it a color. I can give it an edge color. So it's blue, filled red, and they're circles. Okay. I can go ahead and set a title, and I can go ahead and label my X and Y axes as X and Y. And then my second axis, plot onto the right, I'm going to do a histogram. Okay, so in the histogram form, I don't give the separate XY, I give the XY pair of data, so there's data, right? And that's what we defined up here. And then I'm going to go ahead and tell it something about the number of bins that I want and labels I'm going to use. I'm going to add a legend. So we're going to tell it where to put the legend, okay, 0.65 and 0.8 up. We're going to give it a title, and we're going to tell it that the y-axis ticks are on the right rather than the default, which is the left. Okay. We can get into all this sort of thing later. And figure tight layout, just put these close together. So without that, then they'd just be a little separate. All right, so then I can go ahead and run that, and there are my 2 plots set up again by this overall format for the subplots. So we can get pretty fancy here in controlling all of this. If I was to look at it again, just to remind you, so figure is the overall figure, and then this is axis 1, and this was axis 2. All right, so let's say you want to do something a little fancier. And so here, what I'd like to do is I'd like to have one plot that is, you can see size-wise, is twice the size, essentially, of these 2 plots. And in this particular case, we have it twice as tall also as these plots. But this can be however you want to ultimately define this. So in this particular case, for this more advanced layout, we're going to use something called grid spec and then subplot to grid. Okay, and so the way we would set this up is we would actually set up a 3 by 2, so 3 rows, 2 columns. And then what we want to do is tell it that the first axis, axis 1, our plot, is going to span both columns and 2 rows. Okay, so this part of our grid will contain the first plot, and then our axis 2 and axis 3 will be here. So that's the general idea. So you break it up still into a grid, and then you tell it how you want to span a particular figure. So what's that look like? So grid size 3, 2, right? 3 rows, 2 columns. And we're going to give it, here we just gave it the overall figure size that we want this to fit, right? There's still a figure box that surrounds the whole thing. And then we define our individual axes. So axis 1 is going to be our, in this case, we're using that subplot to grid, right? So it uses the grid size. 0, 0 is the start. That's the top piece. That's where our figure, our axis starts, and it says span 2 columns and span 2 rows, and that gives us this. Axis 2 is at position 2, 0. Axis 3 is at position 2, 1. Okay, and you can see how they're labeled here. Remember, our indexing always starts at 0. So the first area here is 0, 0, 0, 1. Row 1, 0, 1, 1, 2, 0, 2, 1. Okay, so 2, 0 and 2, 1 are our bottom positions for these two. So there's the overall format. All right, so let's pull in some data for that particular one, and I've pulled this. Actually, all of this that I've got in this is pulled from this particular website, and so you can look at all this. It's got a lot more details. I just pulled out the highlights for what we need to know. So we're going to call up some housing data, some California housing data. I already downloaded it from the site, and I'll put it into a folder so that you all have access. So I'm going to go ahead and read that housing data, and this is a text file with the data separated by commas, so I have to tell it the delimiter here. All right, and then this has a variety of columns. If I go towards the last column, that's going to be my home price data, so that's what I've got set up as my Y. And then columns 4 and 7 are my population of the area where the home is located, and then the age of the home. And so I'm grabbing these 3 data sets. In this particular problem, they also used a title box. So it's just a way of adding some text into some of the plots. So there was a quick definition just defining how that title box goes in. But basically, we tell it what axis to put it on and then what text that we want, and then it will locate it at 0.55 in the X direction, and then 0.8, 80% up in the Y direction. Okay, and some other coding just for format purposes. So you can play with this and see what it does. All right, but here we go. We got our grid size like we did before, 3, 2. Actually, everything is the same as I showed you up above, so we're going to have the same overall shape. And then we're going to go ahead and fill our axis 1, okay, which is going to look at it's going to be a scatter plot, and it's going to look at the age of the home versus the population area. And then what we're going to do is we're going to color code each point according to Y, which was our home price. So we're going to actually apply color in our scatter plot that is the home price. Okay, and this tells it what kind of color map to use. All right, then we're going to plot a color bar for this. This is basically our legend. Okay, and then we're going to label some things, and then axis 2 and 3, this bottom 2 are going to be histograms, one of age, one of population. All right, and then we're going to add this title box. That was our function up here. And we just want to add in this label home age and area population to the tops of these 2 bottom plots. And then we'll go ahead and show it. All right, so I didn't actually run any of this. Let me run this stuff. Let's just get carried away talking. There we go. All right. Sorry, it hid half my. If you get something like that where it tries to hide a little bit, sometimes it'll do that so that you don't have too much data showing up. You can just click on the left there and it'll open it all up. So there we go. You can see the overall shape of this first, these 2 other plots. There's that text box. These are the histograms, the home age and the area population. This is our main scatter plot, right? This was a scatter plot of the home age down here on the X, the population of the area that the home's located over here on the Y, and then each point is color coded according to the price of the home. Okay, so it's kind of a neat way of plotting. So this, this could be a plot of some kind of property data of a material, where you might have, maybe density down here, You've got some other plot up here. Maybe this is like Young's modulus, and then color coded by the cost of the individual material or something like that. All right. So I'm going to take a quick break. Okay, so let's go ahead and look at the second part of this lesson, which is just going to start us thinking about how to pick points from an image file. Okay, and so the data that we're going to take is we're going to, do maybe if we had an electronic document from the literature, we might take a quick screen clip of a plot in that particular paper and save that as an image file. Okay, and so we're going to need to work with image files. So we're going to go ahead and we're going to tell Matplotlib to use its output in the notebook, which is our notebook here. This allows us to interact with the plots. So by default, Matplotlib works in line, and we don't have the interaction capability. So this part allows us to interact. This will also allow us, if we had a 3D plot, to click on the plot and rotate it and interact with it that way as well. Okay, so we got that step. We're going to import our packages that we're going to need, and the new one that we've got on here is image from Matplotlib, and that'll allow us to read and display images. Okay, and we're just going to call that mpim. All right, so then we're going to go ahead and we're going to go and make our subplots. I just sort of stuck to this longer format rather than just plotting directly like we've done in the past for a single plot. So we have the flexibility, but we can see the overall general form. But I'm going to have one row, one column, so we only have one axis here, one overall figure. And I'm going to give it a size that I want it to plot out. Then I'm going to go ahead and we're going to read the image. So I'll put this also in your folder. So this is just a picture of Jack. Jack is a baby sheep here. A baby doll sheep is the particular type. So we're going to go ahead and read in him, and then we're going to go and show it. So plot.image show is how we would display the image on the screen. And one of the things I'd like to know about this particular image is its shape. And shape means I want to know the number of Y pixels, the number of X pixels, and then the third is the color code, which is a tuple of 3 values. Okay, but what I really need to know is you'll see in a minute, is I need to know what that Y number of pixels is. So this will allow me to pull that out. All right, and then so this is all new, right? This is how we're going to interact with the figure. So the rest of that code just gives me the figure. What I want to do here is I'm going to initialize something called position. I'm going to call it as my variable. This is going to be where my clicks on the screen, where it will save my pixel position. And then we call this event. Okay, so I'm defining something called onClick. This is my naming. I can call this whatever I like. Okay, but onClick is an event, and an event is something in Matplotlib where it's expecting an interaction in some way with the figure. Okay, and in this case, the interaction is a button press event. Okay, so this is actually what defines this particular event. All right, and then what we're going to do is we're going to append on each click on the image. That click will give us an X position and a Y position. Right? And that particular click, again, is just called an event. So this is the way I can get the X and Y position of every click. And it's going to append that onto my variable position. So I can keep clicking away on the image and I get a whole list of positions. All right. And then so I know that something's going on when I'm doing that, I decided to put in a title. So I'm going to go ahead and title my plot. And what I'm going to entitle it is the position of the last click. So right, this is an F string. This is my text. And then I'm going to include a variable, right? And so this is the same format as we've done before. I'm going to put my variable in, and I'm going to just do 3 decimals for this floating point number. Okay. And then the variable I'm putting in is the X data and Y data, just like I've got here that it's saving. Okay, that'll just let us know that something's going on. That's this piece up here. All right, and then this connects it all. This tells it to activate this on this figure, and it tells it to look for a button press event. And when it has this button press event, then it's going to call my function onClick, which means it's going to grab the X and Y and append it to my position. So this is the overall format for this kind of event. All right, and then we'll show my figure. So let's go ahead and run that. All right, so here's my figure. This is how it starts out. There's Jack. So what I can do is I'm just going to go ahead and, so you can see where I last clicked. I'm going to go ahead very quickly and just sort of click around where his face is. All right. So that data now exists in this variable position. So if I go ahead and type in position, there's all the data points that I just clicked. So now I can do is I can just go ahead and plot that. So there's my data. And one of the things to notice is that it's upside down. Okay. So that's one of the things we're going to have to correct with our image plots, is the fact that our origin here is up here in this upper corner. But when we plot things, the origin is always in the lower corner. So I need to correct the Y position here. Okay, so I need to reverse this particular axis so that it's not upside down. All right, so I'm going to do that by simply finding the number of Y pixels in that image size that we pulled off. So 1542 pixels. And I just subtract each of my data points from that overall size, and that'll flip things. So we'll go ahead and we'll do that. And you can see that it flips things back. So that works out pretty nicely. Okay, where data I defined here as a NumPy array of all those position click points. All right, this piece just closes this image, so I can't actually click on it anymore after I run that. All right, and then we've got this. All right, I think that is it. The rest of this is I just pulled together those two pieces to put it into one function, so that now when I click on Jack, the position it gives out directly is correct. So I just made the fix in here, subtracting off that Y dimension, which is the 0 position in my shape of my image. Okay, I think that's it for this week, and I will also post homework to go along with this, but for now you can go ahead and take a look at this document.